Hello! In this video we are going to demonstrate some of the capabilities of Biospytial. So we are working now with the Jupyter server running in Biospytial client. The first thing we're going to do is to prepare the server to load Biospytial modules. For doing this we are going to run these lines. We are interested in this example in mosquitos. So we are going to pick a family node of the type Culicida. Mosquitos, as we can see, is composed of a tree node with family ID and Culicida. We are going to extract the cells from mosquito cells, which are the relations, and then for each one of these cells we are going to extract the neighbors, and we are going to convert it into a set and then again into a list to get rid of any possible repetitions. The length of this is 39 cells that are neighbors of all the cells in which members of the Culicida family were found. Here we are extracting 5 trees out of the sample of neighbors. This can take a little bit of time, and what it is doing is to extract all the occurrences that are within each cell and collapsing it into a tree. So we are creating subtrees, not creating actually, but just extracting. And we can explore the nodes. T1 in this example is the first element of the list, and it has only 5 occurrences. The families in T1 are these, are 4. And now we're going to do some operation with the tree. So I'm going to select the first tree and the first 2 trees, 1 and 2. And each of these has a phyla. Only T1 has chordata, and T2 has several, including chordata. The sum is going to be composed of all the occurrences in T1 and T2. And if we can sum 2 trees, we can sum the entire list of the sample. In this case, remember that sample has only 5 trees. We would like to see if there are some mammals here. Let's try and look. Yes, there are some mammals. Actually, there are 372 mammals. We can extract raster information, also called environmental information. And let's see, because there are 372 occurrences or records. We can extract this table into R. Well, actually we convert it into JSON and then we put it in a Redis connection. Now it's in the Redis database, and we can read this from R using a standard Redis driver. We can explore this the area of the raster of the area. Remember that T1 is going to be only one cell, and the cell is 4 kilometers, so it happens that in this example we have the same value. The resolution of the raster that I'm using is not very fine. So the co-occurrence. With this small function, I'm going to count the frequencies on the big tree. Remember that the big tree we derive it summing all the trees of the sample, and I'm going to count for each of the nodes in the big tree how many of these nodes were also present in the sample list. This is just for verbosing because it was helpful for the developing. We can rank those levels, and we can see that the top 5 of the order are these. So we have some lizards, we have some birds, small birds, pigeons, birds that fish. And we can go even further. We can go by, for example, phyla, just to see which are the phyla that has the most ranking. Or we can go to family. Which are the families that are more related to the occurrence of mosquitoes? And we can see that Asteraceae is quite present. And this type of bird, Corvida, like crows. Okay. Mammals. Can we do this for mammals? Yes, we can do it. We can even rank the levels as well. Remember, because mammals is just another tree. We can do that, and we can see that carnivora, Chiroptera. So all the carnivores were more or less present, 60% present. Bats were also present. And how about the possums? Also present. Mouse and moles. We can do some graph analytics with that. Perhaps we would like to use some standard measure for graphs. No? So here you're just converting the big tree into a normal network X object. We can see here. We can see that here the size of the node is relative to the frequency performed here, like the AF number. And we can use normal graph tools for analyzing. So we can have like the Laplacian matrix or the Laplacian spectrum, which is the shape of that, and so on. Well, here I show some of the capabilities of Biospytial. I hope you have enjoyed the video, and see you later in another demo. Thank you very much.